annuity of 1000. Now in every value, in any kind of value, it may be 10 lakhs, it may be 5000, it may be 50,000. For any value, you can calculate the future value of annuity. By formula you can calculate by putting the value from the future value interest factor of annuity. It is for your better understanding, for conceptual clarity. What is most important is conceptual clarity. So this is my earnest request to you. Please don't skip. Hi, good afternoon everyone. Welcome back to my academic videos. First of all, I convey all of you happy Sunday. So, I was actually discussing the most important topic of finances, that is time value of money. Time value of money, TVM. So, in the time value of money, there are so many small topics are there, like future value of single amount, future value of uneven cash flow, present value of single amount, present value of uneven cash flow. Those things I have discussed. I have already discussed about the doubling period of your investment, growth rate of any investment. So I have discussed growth rate of revenues of things, growth rate of revenue earnings of an organization, just applying the future value of a single amount. I just explained, I shown you in details. So today one of the most important topic I will discuss, one of the most important terms you will be knowing today, this is the annuity. So today I'll start with annuity, A-N-N-U-I-T-Y, annuity. This is the most important things of financial management. Annuity is a annuity. Just remember, annuity is the fixed amount of cash flow, inflow. Suppose you are getting money inflow or outflow, or you are paying outflow in regular interval of time. Interval of time. This is annuity. So it may be yearly payment or receipt, not uneven cash flow. It is a even cash flow. It is a fixed amount. Suppose you are paying the insurance premium every year. This is the annuity. Perfect example of an annuity. So suppose you are paying 10,000 yearly premium of your insurance. Suppose you have a recurring deposit of rupees 1,000 per month recurring. This is also an example of annuity. So this is a fixed amount of cash flow in regular interval of time. Annuity, may be two types of annuity are there. This is annuity due and ordinary annuity. Two types of annuity due and ordinary annuity. Ordinary annuity or deferred annuity. Deferred annuity. So, ordinary annuity is if the payment is made at the end of the, suppose 0 to 0 year. Here it is 0 year, 1 year, 2 year, 3 year, 4 year, 5 year. 5 annuity you will be paying or you will be receiving, cash flow will be there. So 1 year you are paying, suppose 1,000. The next year also you are paying 1,000. Third year you also paying 1,000. Fourth year you also paying 1,000. and fifth year you are also paying 1000. So this is ordinary annuity. So now we'll just show you, consider about ordinary annuity. What is the difference between ordinary annuity and annuity due? I will show you. I will just give you details. Actually, annuity due is equal to ordinary annuity into 1 plus R. That I will show you later on by illustration. Now I will be just focusing on ordinary annuity. One illustration of ordinary annuity. You see, this is a timeline of ordinary annuity. I will show you 0 year you are not paying. After 1 year you are paying 1000. Second year you are paying another 1000. Third year, third, first, second, third, fourth, fifth year. So 5 annuity you are paying. What will be the future value? This is now we will be discussing about the future. Today our focus of concern will be future value of annuity. So you see, how many times this year we suppose the compounding, this is future value, not the discounting rate, the compounding rate. So suppose R is here is equal to 10% suppose. And how many annuity are there? Number of period is equal to here 5. So now we are explaining. I am explaining in details. You see, first amount will be this compounded how many times? 1, 2, 3, 4 years. At a compound rate of 10% for 4 years, this will be compounded. So what will be the value of this one? I have to first calculate. What will be value of this one? Suppose this one will be compounded. So 1000 into, we know very easy, 1 plus 0.1, 1 plus 0.1, 10% is equal to 10% is equal to 10 by 100. Every time I will not do this, so I am just showing you once only. I have shown several times. So 0.1. So I have started directly writing is 1.1 to the power 4 times. It will be compounded for 4 times. So from the calculation I can find the result here. Scientific calculator, very easily. 1.1 to the power. You see the scientific calculator. This is the, I have shown you several times. Again I am showing here. If you, this is the scientific calculator and this is the ordinary calculator. So I am going to a scientific calculator. To the power. To the power. How much? 4 times it will be compounded. So 1.464. It will be 1000 into, just from here I will start, 1000 into 1.464. It will be, what is the amount? 1464 will be the amount. This, the future value of this amount will be that this much, and this amount will be, you see, 1000 into 1.1 to the power 3. So in this way, just I'm just again calculating 1.1 to the power 3, 1.33, 1000 into 1.331 is equal to rupees 1331. After compounding, future value of this thousands will be this much. Future value of first 1000 rupees will be 1464. Second 1000 rupees will be the second annuity will be this much. Third annuity will be, you see, what will be the value of the third annuity? 1000 into 1.1 to the power 2 is equal to 11 into 11, 121. We know 1.21, 1000 into 1.21 is equal to rupees, it is 1210. And the fourth one will be compounded for 1 year only. This will be 1 year, this will be 2 year, 1 plus 2, this will be 3 year, 3, and this will be compounded for 1 year. So 1000 into 1.1 to the power 1 means 1.1 to the power 1 means 1.1 is equal to 1000 into 1.1 is equal to rupees 1100. And last one, after the fifth annuity, this will be at the end of the 5th year. This will not be compounded, because after the payment or receipt, I will get back or I will give back. 5 numbers of annuity at the end of first year, second year, third year, fourth year, and 5th year. After giving that annuity, whole amount I will get back. So for this amount there will be no time for compounding. So this amount will not be compounded. It will be compounded for 0 years. If it is compounded for 0 years, 1 plus 1.1 to the power, suppose I am showing you 1000 into 1.1 to the power 0. Anything to the power 0 is equal to 0 year. This is being compounding for 0 year. 0 year. 1.1 to the power 0 is equal to 1. 1000 into 1 is equal to 1000. So the summation of this 4 amount will be the future value of 5 numbers of annuity. I can easily calculate 1464 plus 1331 plus 1210 plus 1100 plus 1000 rupees. The future value annuity of this amount 1000 rupees will be how much? Future value annuity of, say it is 5 years, how much? This will be rupees 6105. So in this way I can easily calculate the future value of annuity. So this is a lengthy procedure. So we have to know about a formula, how to get the formula. You see, the annuity is annuity value is A. So how many? N is equal to 5 numbers here. R is equal to compounding rate. So we have to know the generalized formula so that it can be easier for us to calculate. So the annuity value is A. Number of period is 5 years. R is equal to compounding rate. So here we can say, so you see what will be the cash flow. The 4 cash flow you have seen. So in this way we can calculate it. You see here what is the formula here? It comes like that. Here 1000 into 1 plus, that is 1 plus 0.1 to the power, how much? For 5 years it was 4. That is 5 minus 1 plus second time it has been 1.1 to the power 5 minus 2. Third one is equal to, this is 4, this is 3. Third one has been compounded, 1.1 to the power 5 minus 3 is equal to 2. 1000 will be there, 1000 plus 1000 into 1.1 to the power 5 minus 4 is equal to 1. And the last one will be 1000 into 1.1 to the power, as I have shown, plus, so I am writing like 1 plus r to the power 1 plus r to the power 1 plus r. I am doing the generalized formula, 0.1 to the power 5 minus 5 is equal to 0. This is the way I can explain. If in place of 5 we can put it n, so the future value of annuity, generalized formula will be like that. For n time will be, if we in all places we can put it a, because the same value a, this is a, and 5 is equal to n. So we can put it like this. Generalized formula, a plus 1 plus r, 0.1 is equal to r to the power n minus 1. You see, first one is n minus 1, second one is equal to a into 1 plus r to the power n minus 2. You've seen r to the power n dot a into 1 plus r to the power n minus 1, and last time it will be n minus n is equal to 0. So what will be n minus n? A to the power n minus, here it is be n minus n, you see, n minus n. So it is 0, n minus n is equal to 0. And the previous one will be a into r to the power n minus n plus 1 is equal to, this will be the same. So what will be the value? You see, a into, so what will be the equation? A into 1 plus r to the power n minus 1 plus a into 1 plus r to the power n minus 2 dot plus a into 1 plus r to the power 1. This one is equal to a into 1 plus, actually this is not like this. You see, I am showing you. A into 1 plus r to the power n minus n. So a into r to the power n minus n is equal to 0. Anything to the power 0 is equal to 1 is equal to either. We can consider this one as a. So these are the generalized formula. Equation 1. This is equation future value of annuity. Equation 1. This one. Equation 1. This one is equation 1. You remember this one, equation 1. Now, if we multiply both sides with both sides with 1 plus r. So what is the situation? You see, future value annuity into 1 plus r. This is the left hand side, and right hand side every time will be multiplying by 1 plus r. So first term is a into 1 plus r to the power n minus 1. What you see here, a into 1 plus r to the power. So we are just multiplying by 1 plus r. This is x and this is also x. So n minus 1 plus 1. So a into 1 plus r to the power n minus 1 plus 1. This way it will be cancelled. So the result will be a to the power n plus 1. The same way it will be again plus 1, 2 minus 2 plus 1. So it will be minus 1. It will be a into, second item will be a into 1 plus r to the power n minus 1. And third item will be a into 1 minus a into 1 plus r to the power n minus 2. In this way you go there and plus here we will calculate another one. This one has been A. This has been A. I'm just finishing. This is A. I have shown you in details. Now I am showing this. So this will be A into 1 plus r to the power 2, and this is A into 1 plus r to, this is A into 1 plus r. And r to the power 1 here, and another 1 power will be added, so r to the power 3. This is equation 2. This is equation 2. Equation 2. So this one is equation 2, and multiplying with 1 plus r, I get the equation number 2. Equation 2 minus 1. What I will get? You see. This one will be, it will be multiplied. This is 2. Future value of annuity. Future value of annuity plus future value of annuity into r. Minus second minus 1. This one second. Left side will deducted, and right side will deduct. The left side it will be first future value of annuity plus future value of annuity into r, minus this one future value of annuity. This is the left side. This term will be after multiplication, it will be 2 terms. This one is a 1. This one will be 2, and this is a single term, so it has been put. It has been kept here only. Future. It has been kept here as a future value and annuity only. And then this side you come here. This first term will be cancelled by the here second term, because this minus this will be cancelled, and here it will be another 1 minus 2. Here you will be finding this one will be cancelled by this one, a to the power 1 plus r to the power 1, and a to the power, you see, a to the power 1 plus r to the power 1, a to the power 1 plus r to the power 1 cancel. Here also the previous terms will be, previous number will be a into 1 plus r to the power 2. So this will be cancelled by this one. So we are just remaining this one in the first equation and this one in the second equation. So this will be, if we deduct, if we subtract 1 from 2, subtracting, here I have to write subtracting, I have equation 2 minus 1 I have shown. The language will be subtracting equation number 1 from equation number 2. I will be getting here is equal to a to the power a into 1 plus r to the power n plus a. So here you can take the a as a common, then 1 plus r to the power n plus, sorry, this one will be minus, this will, because this one minus this one will be minus, this one will be minus sign, subtracted, so minus 1. This is the form I got. So here you see future value of annuity, I am cancelling. So future value of annuity into r is equal to what I am getting? A into 1 plus r to the power n minus 1. So the future value of annuity for n years, you see how details I have explained the formula. I have explained how I have extracted the formula. I don't think in any of the classes you will find this way. I am explaining in details how I have got the formula. Future value of annuity n is equal to. So please go through my video thoroughly. You will have a good idea. You will have a very clear concept. Conception is very important, because you can put any value there and you can find a value. But conception, how it has come, how it is extracted, how this formula has been extracted, that is very important. I am showing you here. So future value of annuity is equal to what I can do here? A into 1 plus r to the power n minus 1 divided by this r. This, you see, this r, it will be coming here because only I have written future value. So both sides I am dividing by r. If I divide this side by r, if I divide this side by r, and this side also by r, so it will be conserved. So future value annuity is equal to r. This is the formula. This is the formula for future value of annuity. It's a very important one. So I am writing here. For your better understanding, in a clear way I am writing here. So what is the formula for future value of annuity? Future value of annuity, the basic formula is A is equal to the annuity into, you see, A is equal to 1 plus r to the power n minus 1 by r, where r is equal to compounding rate, n is equal to the period, payment period, and A is equal to the annuity. So you get what will be the future value of this annuity? A into third bracket 1 plus r to the n minus 1 by r. This term is called the future value interest factor of annuity. The same way I told you, this is the formula. I have extracted the formula. I have explained how the formula have come here. You just write down, please. That is why I have not erased it. This is the formula. From this formula, I find what is the formula of future value of annuity. Future value of annuity is equal to annuity into 1 plus r to the power n minus 1 by r. This part of this formula is future value interest factor of annuity for r% and year. This portion we can easily calculate from, find from the table, future value of annuity table up there, and I will show you that one. I have shown you here how much is the value. I will put it from the future value and interest factor annuity formula, and I will put the value here. By the formula also, I have shown in details here. This is by timeline I have shown you. Now putting the value in the formula and taking the value from interest factor, taking the interest factor the annuity, future value interest factor, taking the value of interest factor the annuity from the table. I will put there. The both way I will calculate and I will find the value here, you see. So what I have to do, some portion I have to actually erase. So this portion I am just erasing, but this amount I have to keep, this amount. So here is equal to 1000, no, annuity is equal to 1000, R is equal to 10%, and this is a compounding rate, and n is equal to 5. Now putting all this value here, I can easily calculate. Now first putting the value. So value, future value interest factor, future value of annuity is equal to, A is equal to 1000 into 1.1. This is 1.1. I can write 1.1 to the power n. This is 5 minus 1 by 5. This way I can easily calculate. This huge, big explanation I can get within 1 minute from here. You see, I am just stating it. 1.1 to the power 1.1 to the power 5. 1 point, what will be the value? You see, 1000 into 1.6105 minus 1 divided by 5. Now it will be 0.6105 divided by 5. Sorry, here it will be 10%. R is equal to 10.1. will be 0.1. It will be 0.1, and it will be 0.1, it will be 0.1. So what can I do here? You see, divided by 0.6105 divided by 0.1. 6,000 into 6.105. 6.105, and what is the value? Is equal to 6,105. It took around 15 minutes to find out this value, and I have just found out just within a minute 6105 by putting the values in the formula. The next, another way I will find out, I will be just showing you here that one, that putting the value from the table. So you see how interesting everything is. You see, we have got this much. So we have put everything and got the result. Now getting the result from using the future value interest factor annuity for 10% 5 years. Here A is equal to 1000. Within a second, we can calculate what is the future value of annuity is equal to A into 1 plus r to the power n minus 1 divided by r. So A is equal to 1000. This part is nothing, future value interest factor annuity, 10% 5 years. So this I will put from the table. I am just showing you. I'll show you just 1000. This much future value interest factor of annuity from the table. I told you in every financial year's book, and in the book of every financial management, in the last of the books, you will find the table of future. This is future. You see, this is future value interest factor table, FVIF. Then you got the future value interest factor annuity table. Here is the future. One way you see the formula is given here. 1 plus r to the power n minus 1 by r. 1 plus r to the power n. This portion is future value interest factor of annuity. You see, this is given here. You see, 10%, 0, 1, 2, 3, 4, 5. 1 per 10%, 5 years. These are the column are the percentage of compounding you will find, and the row you will find the year, that is period. This is clearly it is 10% 5 year 6.105. So directly I am putting the value 6.105. After putting the all values here and calculating here with a critical calculation. So this one is easier than this one, and this one is much more easier than this one. So I am showing in every way. Generalized formula I have shown. From this formula I have put the value here. I have got the future value of annuity for 1000 for 5 years. Here. Now putting the value from the table, I am getting it is again rupees 6,105. So in 3 cases, you see, in all the 3 cases, the value has been saying 6,105 by timeline. First I have shown you by using the timeline for your better understanding, showing the future value interest factor of annuity by timeline I have shown you first. Then I have found out a generalized formula for future value interest factor of annuity. In every book you will find this formula easily, everywhere you find. But how it has extracted, the explanation of this formula, how it has come, how the formula has been extracted, that I have shown in details here. From here I have shown you in details. Before showing it, I have also, from this timeline I have got the generalized formula I have shown you here. You see, this is called the better understanding, conceptual clarity. This is called conceptual clarity. First of all, you should have a conceptual clarity what about any topics, any things you have. When you have got the conceptual clarity about this thing, then no matter whatever, you can forget the formula, but conceptual, if there is a conceptual clarity, you can find out it very easily. First, I have shown in the timeline. From the timeline, all the 5 items I put here, and after adding all these 5, the future value of all the 5 annuity I have calculated, and after that separately for every annuity future value of single amount I have calculated here. Calculating all the single amount, future value of single amount, I have got this 5 single amount, and I have added this 5 single amount, and I have got the future value of annuity of this amount, this one. After that, I have explained you how this can be converted into a generalized formula. This way, from here I have come in case of annuity, I have put A, and 1 plus 0.1 is equal to 1 plus r to the power n minus 1, n minus 2, n minus 3. In this way, I have got a generalized formula, equation 1, and multiplying equation 1 by 1 plus r, I have got equation 2. Subtracting equation 1 from equation 2, I have got this one, this formula. This is the formula. Future value of annuity is equal to A into third bracket 1 plus r to the power n minus 1 by r. This way. So this is formula. Now I got the formula. In every book, everywhere you will find the formula. But nowhere you will find it the way it has been calculated, it has been shown, it has been explained, it has been elaborated, you will not find. So please, for your better understanding, for your clarity, please go through my video properly, thoroughly, don't skip. So here I have shown you just for annuity of 1000. Now in every value, in any kind of value, it may be 10 lakh, it may be 5,000, it may be 50,000. For any value, you can calculate the future value of annuity by the formula, by using the future value interest factor of annuity. By formula you can calculate by putting the value from the future value interest factor of annuity. But this one, for your better understanding, for your conceptual clarity, this one you should not be using. It is for your better understanding, for conceptual clarity. What is most important is conceptual clarity. So this is my earnest request to you. Please don't skip. Just go through my video thoroughly. Maybe it is little bit lengthy, but for your better understanding, I have tried my level best to explain in details. Thank you so much. Have a nice time. Bye. Take